Good morning, students. Welcome back to the session. So we were discussing about the CET NEET concepts based on the integrated rate equations under the chapter chemical kinetics, right? So till now we discussed about molecularity, order, as well as rate expressions. So this is an important topic where you are getting the chances, maximum chances to get the problems based on these concepts. So please practice the derivations what I have taught in the previous class, that is integrated rate equation of both first order, zero order as well as their respective half-life period. Okay, by that you can easily clear the problems. Okay, here I have chosen a few questions based on that. Let me solve this. Okay. Right, and these were the basic concepts what it comes under zero order and first order that we discussed. Okay, I thought you have written this. Take this as a synopsis and please go through that. Yes, we will begin with the first problem, that is 23rd problem. Read out the question carefully. Right, so 99% at a of a first order reaction was completed in 32 minutes. When will 99.9 of the reaction complete? Okay, ನೋಡಿ ಇಲ್ಲಿ ಏನು question clear ಇದೆ. 99% reaction, first order reaction complete ಆಗ್ಲಿಕ್ಕೆ ನಮಗೆ ಎಷ್ಟು time ತಗೊಂಡಿದೆ? 32 minutes. So that means percentage, from percentage initial concentration as well as final concentration you can extract, right? And time is given, that is 32 minutes. So this is about the first one, this thing. And at the same time, second one, 99.9% of the same order reaction complete ಆಗ್ಲಿಕ್ಕೆ time ಎಷ್ಟು ತಗೊಳುತ್ತೆ? So again from here we can extract the initial concentration as well as final concentration, right? So ಇಲ್ಲಿ time ಎಷ್ಟು ತಗೊಳುತ್ತೆ ಕಂಡುಹಿಡಿಬೇಕು. So this is our question and options are given here. So let me solve this first. First let us begin with the first one. Take this as first and take this as second. Okay, first one, the equation is K is equal to 2.303 divided by T. Time is given for first one. What is the time? 32 minutes. So that I am going to write here. Is it into log initial concentration. Whenever the percentage is given, percent means 100 again. So initial concentration is always 100 and final will be 100 minus the given percentage, that is 99. Okay, this is how we can express the equation of first order reaction. Similarly, second one, K is equal to 2.303 divided by time we don't know, time of 99.9% we have to find out, log initial concentration is 100 and final is 100 minus given percentage. So what we are going to get here, see the same elements or same value whatever you have in the equation 1 and 2, you can cancel them. So K got cancelled and 2.303 get cancelled. So consider this as equation 1 and this as equation 2. So now take equation 2 divided by equation 1. Then what we have in the equation here is 2. So that we will write first and then we will go with the second one, first one, right? Now, so T, fractional ide, so T comes first. Or else you can directly take 1 by 32 whole divided by 1 by T 99% antanu tagobodu. Directly I am taking T 99.9% divided by 32 is equal to, illi nodi, log 100 divided by 100 minus 99 andre 1 alva. 100 by 1 is nothing but 100 only. So ille nodkolutte log 100 divided by log, yes, 100 divided by illi 0.1. 100 divided by 0.1 andre, so this becomes 1000. So that goes up. Nodi illi idishtruddu value enagutte, log 100 agutte. 100 by 1 is nothing but log 100. Illi log 100 divided by 0.1 alva, andre enagutte 100 divided by 0.1 is nothing but 1 by 10. If this goes here, it becomes log 1000. ಓಕೆ ಫಸ್ಟ್ 2 ತಗೊಂತಿರೋದ್ರಿಂದ 1000 ಇಲ್ಲಿ ಮೇಲ್ ಬರುತ್ತೆ, ಇಲ್ಲಿ 100 ಕೆಳಗಡೆ ಇರುತ್ತೆ. ಇಕ್ವೇಶನ್ 2 ಫಸ್ಟ್ ಬರಿಬೇಕಲ್ವಾ, ಸೊ therefore 1000 goes up. ಇದು ಹಾಗೆ ಇರಲಿ, t 99.9% divided by 32 is equal to log 1000 is nothing but 3.0 divided by log 100 is 2. Therefore t 99.9% is equal to 32 into 3 divided by 2. So what is the answer? 96 by 2 is nothing but 48 minutes. So our answer is option A. Okay. So here is our next question. The rate for a first order reaction is 0.6932 into 10 to the power of minus 1 moles per liter per minute. See, first order reaction, the rate for a first order reaction is this one, rate and the initial concentration of the reactants is 1 molar concentration. T half is equal to, okay, here you can observe the unit, this is of half-life period. So T half we need to calculate and its rate is already given. Okay, the rate of the reaction is given. How to calculate the T half for 1 molar concentration of the reaction, right? So what is the formula for T half? Don't get confused. Illi half life kelidaralla, navu half life formula hakana. Okay, K is equal to 0.693 divided by T half. This is the formula. So we need to find out T half. Therefore T half is equal to 0.693 divided by whatever value they have given, that I am going to write here, that is 0.6932 into 10 to the power of minus 1. Okay, so whatever value they have given, that I am going to write first. Sorry, so this should be 10 to the power of minus 2. Sorry, this is a printing mistake. 10 to the power of minus 2 is there. Okay, this is minus 2, correct. Okay, nodi 0.693 divided by 0.693, this can be cancelled. What is left over? 1 divided by 10 to the power of minus 2 is nothing but 100 anta barkobodalva, andre inverse, right? So if this goes up, then or else you can take like this, 10 to the power of minus 2 ಮೇಲೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, 10 to the power of plus 2 ಆಗುತ್ತೆ, that is nothing but 100 minutes. Therefore option B is correct. Understood? ನೋಡಿ ಇವೆರಡು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ದೀನಿ, ಇದು ಮಾತ್ರ ಉಳ್ಕೊಂಡಿದೆ, ಅದು ನ್ಯೂಮರೇಟರ್ ಗೆ ಹೋದಾಗ 10 to the power of plus 2 ಆಗುತ್ತೆ, that is nothing but 100 minutes. That's it. Okay, now the half-life period of a first order chemical reaction is, half-life period idu kottidare, that is T half is equal to 6.93 minutes. The time required for the completion of 99% of the chemical reaction will be, adu estagutte. Okay, let us calculate. So let me write the given data first. T half is given, that is timings is given for a half-life first. The time required for the completion of 99% of the reaction. From this we can extract the initial concentration, that is 100, and final concentration, that is 100 minus 99 is equal to 1 of the chemical reaction will be eshtu anta kelidare, log 2 value is given. Okay, so now let me find out the first order reaction ge ನಾವು first equation na barkolana, that is K is equal to 2.303 divided by T into log R naught divided by R. So this is our formula. So we don't know the value of K and timings they have given, but it is of half-life period. But idu first order reaction, only R naught and R we know. Okay, by using the given time, first let me calculate the value of K. Half-life period formula is T half is equal to 0.693 divided by K. So T half is given, therefore take K here, 0.693 divided by what is given, 6.93 minutes. So the fraction ಎಷ್ಟು ಬರುತ್ತೆ ನಮಗೆ, 0.1 per minute is the value of K. From given half-life period, rate constant has to be extracted first. ಸೊ ಈ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ನಾವೀಗ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. So then we can calculate the T. So just rearrange the formula. T kade tagoli. T is equal to 2.303 divided by K value is 0.1 log initial concentration is 100 divided by final concentration is 1, right? So T is equal to 2.303 divided by 0.1. So log 100 value is nothing but 2, right? Therefore T is equal to, let us calculate this. .303 into 2 divided by 0.1. So the answer is 46.06 minutes. So let me check whether the obtained answer is there in the option or not. 230, 23, 46. Yes, 46.06 minutes. Exact answer we got. And there is a option also. So that is option C is correct. Okay. Okay. So next question is rate of which reactions increases with the temperature? Okay, rate of a reaction is directly related to concentration as well as temperature. As the temperature increases, rate also increases. Okay, first option is this is a relation between rate and the temperature. Okay, of any reactions, of exothermic reactions, of endothermic reactions, of none. Okay, see rate increase adaga temperature increase agutte. It doesn't matter whether it is an exothermic or endothermic. So that depends on the molecules which are involved in the reaction. ಅದು ಎಕ್ಸಸ್ ಹೀಟ್ ಅನ್ನ ಹೊರಗಡೆ ಹಾಕಿದ್ರೆ ಎಕ್ಸೋಥರ್ಮಿಕ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಕ್ಸಸ್ ಹೀಟ್ ಅನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಎಂಡೋಥರ್ಮಿಕ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಬಟ್ increase in temperature always increases the rate, whether it is an exo or endothermic reactions. That doesn't matter. Therefore, it depends on all the reactions. Okay, so therefore of any reaction is a right option. Don't get confused. Okay. Next question is for a zero order reaction which of the following statement is false? Nodi yavadu tappide adanna ನೀವು find out ಮಾಡಬೇಕು. The rate is independent of the temperature of the reaction. No, just now I told you temperature is directly related to rate. Whether it is zero, first order, any order of the reaction. It is not independent, it is dependent. Let me see other options. The rate is independent of the concentration of the reactants. Yes, ನೋಡಿ zero order reaction ಗೆ ನಾವು ಏನು ಬರೀತೀವಿ? K is rate is equal to K into R to the power of 0. R is the concentration. Here is a 0. So it is not depending upon the concentration. Okay, independent of the concentration. Yes, it is correct. It is not false. The half-life depends upon the concentration of the reactants. Yes, rate is independent, but half-life is dependent. Well, how we are going to write? T half is equal to 0.693 divided by K. It is depending. Depend agida. Okay, half-life is depending, but rate of the concentration is independent. It is also correct. And the rate constant has the unit moles per liter per second. Yes, this is also right option. Therefore, option A is a false one and the correct option is A. Okay. Yes. So next question. A large increase in the rate of reaction for a rise in temperature is due to a large increase in the rate due to the rise in temperature. Yes, rate is directly proportional to temperature. As temperature increases, rate also increases. Increase in the number of collisions, the increase in the number of activated molecules, the shortening of mean free path, the lowering of activation energy. See, all the options are matching with this concept. But the accurate one is option B. The increase in the number of activated molecules. Just by the collisions, the rate will not increase. And just by shortening the mean free path, rate ಗೆ ಅಷ್ಟೊಂದು effect ಮಾಡೋದಿಲ್ಲ. Obviously, the lowering of activation energy will increase the formation of an intermediate. But this also affects the rate in a positive way. But the accurate one is the activated molecules. First, the molecules have to be activated according to Maxwell velocity graph or plot. Okay, according to Maxwell velocity, it is a factual question, velocity plot, this is the right option. Okay, so here is about the integrated rate equations related problems. In the next class, we'll continue with the problems. So till then, you practice these problems and even practice the derivations also. You'll get homeworks based on this. Okay, thank you, students.